Friends, hello everyone! Today is our last lesson. We are finishing up our course, and throughout the course we have only interacted with the TON blockchain through the console. We have only interacted with contracts in test, and in order to finish the course in full, I would like to show you not only the tests, but also how contracts will interact with the outside world. Therefore, the final lesson of this course will not be about contracts. We will focus on how to integrate contracts with the outside world. Together we will create a decentralization application, dapp, interacted with the TON blockchain. It will be able to read information from the blockchain and send messages to blockchain. We will integrate this throughout TONConnetct, which allows for the integration of crypto wallets such as TONKeeper, which we installed on the first lesson, and integrate this with a smart contract. I've already deployed this contract, the Jeton contract we discussed on 8th lesson. I've deployed it using the main TONCore repository. The Jeton is represented in 3 contracts: master, messages, and wallet. In the end, we will integrate our dapp with Telegram web application for complete ecosystem integration, where our backend is smart contracts and where our frontend is site which will public on GitHub page and integrate with Telegram. So let's start. To save time, I've already created a small project in React. Let's look at the code. Here you can see that this is a standard React application. Styles written directly in app TSX. Styled components as a button written by hand in the styled folder. In this app, there is only one element, Jeton. Let's go into it. And on Jeton page, we are going to implement several things. We will implement displaying the user's wallet, displaying the Jeton wallet, and balance in Jetons, and also the mint method for this Jeton. The next thing I prepared in advance is the wrappers and build folders from the tagged project. As we remember, our contracts are already wrapped in TypeScript, and we can look here. This contract is actually the Jeton master. It has methods like mint, get wallet address, get Jeton data, and so on. The second contract is Jeton wallet. We can also go and see what methods it has. It's called Jeton default wallet, and it also has several methods. Okay, let's first connect to the TON blockchain and enable our crypto wallet to connect to our application and display the address of our wallet in our application. To start with, the first library I will install is TONConnetct. Okay, the first library is installed, and to integrate our TONConnetct, we need to wrap our application in the TONConnetct provider component from this library. Let's import it and wrap our application in it. TONConnetct provider has one important attribute that we'll integrate now, the manifest URL. It will contain a link to a JSON file with information about our application, and we'll do this in the last step. For now, we will leave it as it is. Okay, let's move on to our app and add TONConnetct button here, which we can use to connect to our application through the crypto wallet. Now let's start in dev mode and see what we get. Great, the button has appeared, and we can click on it to see how to connect. A QR code has appeared, which we can scan from our phone to connect to the application. There is also ability to see which wallets TONConnetct supports, and we will use TONKeeper. There is also option to open it via an extension if we had one installed. Alright, we won't link up right now. Instead, we will create a feature to identify the wallet address that's connected to our service and also the network we are using. It will tell us if we are on the testnet or mainnet. For this we will need a few more libraries. Let's install all the libraries that we will need for this project at once. We will need TON, TON Core, and we are also going to install TON Access from company Orbs, so that we can read from the blockchain through the free point. Great, now let's start our integration. Let's create a hooks folder, and the first hook we will write here is use TONConnect. Use TONConnect is a function that will return several fields for us, such as sender, field connected with the flag true or false. It will also return the wallet address in string format or null. And network. Here is already chain type or null. To extract this data we will need several methods from the TONConnect library. The first thing we will get is TONConnect UI object and use TON wallet to get address of our wallet. Now we will return our object. The first field is sender. As we remember, if we open its interface, the main thing that should be it, and the second, optional, is the address field, where you can get the wallet address. So first let's implement a send method. This will be an asynchronous function that will take arguments, and these arguments will also be typed through the sender arguments type from TON core library. Let me specify the other fields here right away, so that our TypeScript doesn't complain too much. And the transaction will be sent through the TONConnect UI object. We will call the send transaction method, and two arguments will be passed here. The first is messages. Our messages will be in array format, meaning there can be several of them. The second field is valid until. This field defines how long they will be valid to send on the blockchain. Let's specify that they will be valid for 5 minutes. In the messages field we will pass only one message, and we will pass an object here with the following fields. The first field is address, to which contract we will be sending message. The next one is amount, and the third one is payload. Payload is the body of our message, and the message body is represented in the format of cell, and the cell needs to be converted to base 64 format. For this we will use the following methods, and that's it. Our send method is ready. It will be universal for any messages that we will send in the future. Let's continue filling in the fields. And we will get the address from the wallet object, which we extracted using useTonWallet. And here our TypeScript complains because it expects either address or undefined type, but we have string or undefined. So let's cast it in the following way. Okay, now it's complaining about other fields. Let's continue filling our return object. Next is connected field. So now I'll do this so that we can see if our code is correct. Okay, I will initialize connect field in the following way. If we have some address in our wallet object, this means that we are connected. If there is no address, it means that we are not connected. In field wallet we will pass our address. And we can also get network from our wallet account chain. Okay, we wrote our first hook. It may seem complicated and unclear at first glance, but let's create simple functionality with it. We will define which network we will connect to. For this, we call it in our app component and import our network as follows. Let's try running our project. Here we also see an error that we also need TONConnetct library. Let's install it. And now our project has launched. Let's open it. Great. And the last thing we will do before connection the wallet is to return to our main and put the following link in the manifest URL. The manifest is a JSON that has 3 fields. It's a URL that points to our app's link, its name, and you can also put an icon so that the TONKeeper wallet identifies our app with an icon. Okay, let's pass our manifest URL and go back to the site. So I click Connect Wallet, scan it from my device, and yes, I see the opportunity to connect to the project. For this, I need to click Connect Wallet, and I also see the name of our application indicated in the manifest. It's example. Okay, I click Connect, and now my wallet is connected to our site. We can confirm this by clicking on the button again. We can copy our address, and we also see that some value appeared in the network tab. And this value is minus 239. It's exactly the identifier of our mainnet. Let's go back to our app tsx file, and here we'll make the following check. First, we'll check that if network exists at all, and the second check is on what exactly network will be. We can also use a ready-made chain object from the library here, and the chain object has already 2 fields. These are mainnet and testnet. Let's choose here mainnet, otherwise testnet. Or if we didn't have any network at all, we will also indicate this. Okay, let's check if this works. Yes, indeed, we see mainnet. And let's disconnect. And now it shows that we have no network. Great, it works. The next thing I want to do is display my wallet address after wallet field. And also, if we have not connected our wallet, make the mint jeton button disabled, so that we could not click it. For this, let's go to jeton file, and here we will need to use our hook use TONConnect, from which we will get the fields connected and wallet. Let's do this now. In the wallet field, I'll add our address and use the connected flag to determine whether my button will be disabled or not. Let's check if this works. Yes, we see that the result is expected. Now let's try to connect our wallet. Okay, and everything works, only I don't like the format in which the address of my wallet appeared. Let's correct this now. Okay, it works now, and we are ready to integrate our token contract into application. For this, we first need to write 2 tools, namely 2 hooks. The first hook is the most common for us. It will be called useAsyncInitialize. We will use it to initialize our contracts, and in the case there will be any changes, our hook automatically reinitialize the contracts. If you are not familiar with React, this part of code will be unclear, but it's okay. This has nothing to do with blockchain development. We will only use this function as a tool. And now we are ready to write the main hook in the development of our contracts. This hook is useTONConnect. This function will return us a client that is connected to the blockchain nodes, and with the help of this client we will be able to read information from the blockchain, as well as send transactions to the blockchain. For this, first let's define what network we use for this. We already have our ready hook, use TONConnect. And now that we know which network we are working with, we will immediately define our client after the keyword return. And to define what is a client, we will use the just written tool use async initialize, which as the first argument will accept function that will actually create our client. And the second argument will accept an array of dependencies, and if any of these dependencies change its value, our client will be reinitialized. This is exactly how the use async initialize works. So our function will be asynchronous, and first let's check that our network exists. And if the network exists, we immediately return the object new TONClient. Now, when we are creating a client, we need to specify an endpoint to which we will connect. And here the library TONAccess will help us. It provides us with a free API to access the blockchain. For this we will call get HTTP endpoint function, which is taken from Orbs network. And here we just need to specify which network we need, testnet or mainnet. Great. And as dependency, we will pass the network. Now, if we disable our wallet in our app that is connected to the mainnet, switch to testnet in the app and reconnect, our TONClient will automatically determine this under the hood, reconnect to the testnet, and all this happens without refreshing the page. But we are not doing this, and we are moving on to the integration of our smart contracts. For this, I create the last hook for today. It's use jeton contract. First of all, I get the client and initialize the jeton contract. For this, I will use the hook use async initialize. Here, I also first check if my client exists. And if it exists, I will continue to create my contract. At this point, I will need my build, which I transferred from the tagged project. Let's take a look again at what file exactly I need. It's this one, jeton, and let's go to build, and from here I copy name. I put it here. Okay, and since I have already deployed this contract, I will initialize it from address. I already have the address. I'll write address, parse, and here I need to put the address. I'll put address of contract here. Now all I have left to do is open my contract via my client. That is, as you remember, when we were writing test, we had a blockchain object instead of client. Now our blockchain has become a client. That is, the client is exactly our access to our blockchain. Therefore, within this client, we open our contract. And it'll be type contract jeton. Good. As a dependency, we will also pass him the client, so that if our client, for example, reconnects to testnet, our jeton contract will also automatically switch to jeton with testnet. But for now it doesn't matter because I have not deployed this contract to testnet. Now we are working with mainnet. And now, as you understand, when we have jeton contract, we can call all the methods directly from the blockchain. That is, get jeton data, get wallet address, get owner, and so on. And now, through the jeton contract, we will get the contract of our jeton wallet relative to our regular wallet. And from this address, we will also initialize the jeton wallet contract. Let's declare the jeton wallet contract here. and get its address. And here, as an argument, we need to insert the address of our regular wallet. We can get it through another of our hooks, specifically use TONConnecct. TypeScript is complaint here. Let's also indicate that the wallet should be connected. And now, through the client, we can also open our Jeton wallet contract. Let's now look at what our Jeton wallet contract is called. And import it from our build. Great. Here we initialize two our contracts, Jeton contract and Jeton wallet contract. Let's also pass the Jeton contract as a dependency here, so that if our Jeton contract changes, our Jeton wallet contract will also change. And now the first thing we will return from this hook is the address of our Jeton wallet. Now, in the Jeton component, we can get it. It should be in this component. And let's check. Yes, indeed, our Jeton wallet address has loaded. We just have to pull up the balance and form message on mint jetons. Let's finish reading from the contracts, pull up the balance for this. Let's go back to our use Jeton contract hook and close other files, not to get confused. I'll create a separate state for this, call it balance, set balance, and after all the contract initializations, I'll get the balance using useEffect. I'll declare here an asynchronous function, getBalance. Of course, we'll be checking whether our Jeton wallet contract is initialized, put it in the dependencies right away, and get the balance in the following way. Next, we will set our balance, only we also need to convert it from the Nano Toncoin format to readable view. And here TypeScript complains that we didn't type our balance. Let's type it as a string. And here we'll call the getBalance function. And now we are ready to return it. Okay, here we have returned it, and here we have received it. And now, instead of loading, we can check if our balance is equal to something, and if yes, then we will return it. If no, then we will output the message loading. Let's check if it works. Yes, indeed, we see that the balance is exactly the same as in my wallet. Great, the last part of our application is left. It is to write a method for mint jetons. We will also do this in our use Jeton contract file. And since there will be a future to send a message, we will also use our second hook, which we wrote in advance. It's use TONConnecct, which returns us sender with a method for sending any of our messages. Let's get it inside our use Jeton contract file. The first thing we do here is to initialize the message we want to send. Our message will be of type mint, which, as you can see, is import from our build, from our wrappers folder. Then we initialize it the same way we did in the tests. We specify the type here. Visual Studio suggests us the name mint, then field amount, and as amount let's mint 150 jetons. Okay, message was formed, and now we take our Jeton contract, call its send method, pass it the sender, then pass value, and pass the message. As you can see, everything is exactly the same as we did in the test. Let's now just get it out and pass to button. And before we test and send our mini transaction, let's slightly improve our getBalance method and make our balance change without reloading the page. For that, we need the getBalance function to call itself every 5 seconds. I'll write a sleep function here that will help us with that. It will take time as an argument. OK, and let's call the sleep method every time after getting the balance and then call it again. Super. And let's now check that everything works and try to mint our tokens. So we see that we have a transaction confirmation appeared. I click confirm. And yes, my balance has changed. Thus, we have created a dapp that can interact with smart contracts, can read the state from the blockchain, can send messages to the blockchain, connect crypto wallet to itself, and also switch on the fly between the testnet, mainnet, and any contracts. That is, for example, we can now replace the address of our master jeton, and our application will work with it in exactly the same way. In preparation for this lesson, I used the TWA template repository, and it's completely open source. You can install it for yourself to quickly get all the tools that we wrote and immediately get decentralized application template. We can look at what contract was used here as an example. Here is another naming, and let's try to copy such a contract here, add it when initializing our jeton. And as we can see, everything has changed. Here we just got an interesting bug. Let's fix it. It goes to get our balance. Let's always reset our balance to an empty string by default. So far I don't really like how it works. Let's refactor a bit now. Let our balance be not only a string, but string CONNALT. By default there will be nothing here. Here we will set it to null. Well, okay, our balance doesn't work very perfectly, but what we want to check is that even when changing the master jeton contract, our functionality will work. Okay, everything went successfully, that's all. Our application is ready, and now we just need to integrate it into a Telegram web application. Let's close all unnecessary things now, stop our application, and for this we'll need the following library. And now we just need to import this library into our app.tsx file. And great, we are ready to deploy our project. We will deploy our project on GitHub page. To deploy our project, we will first need to open a tutorial on how to do this in parallel. First, we need to add to our packages on this line. And here we have such a structure that we need to add our GitHub username and repository name. Let's go to my GitHub. Here is the project that I deployed with you from the repository. I copy my username and copy the name of repository. Next, I will need to install the GitHub pages library and add the following scripts. Great, the library is installed. And let's do the last things before the deployment. So my Visual Studio is complaining. Most likely it's just a bug. but just in case, I will check it. So yes, I think it's just a bug. Well, let's look here as a base path. I need to specify path to my directory. In this case, it will be a TWA template. I insert it here like this. And in this part, friends, it's time to think about the manifest JSON, where there will be information about our application. I prepared such a file in advance, where as a URL I specified a link to our project. The name will be my TWA. And for icon, let's choose it together now. Well, let's put the MetaMask icon. Okay, great. Now let's deploy our project. I will stop the process, so an error here. In this case, the build will upload, but we need to publish dist folder. So let's fix this. Great, the project is published, and now we go to our GitHub, refresh the page, and here in the page tab we should see, yes, indeed, site has appeared here. And if we go to it now, we see an error. Let's check. We go to GitHub page branch, and yes, we can see that our project deployment continues. Let's wait for that. I had a small problem with GitHub, and I had to create a new repository. I name it my TWA, and also rename it in all my configs. And also we should not forget to change our manifest URL, because it's located in the public folder, so we should specify it as follows. Okay, and let's repeat our deployment again. So the deployment is starting. We see the action started on GitHub here. Okay, so I see that the action has ended, and let's take a look at our site, try to connect it, and yes, indeed, we see that everything is working as we expected. Our icon has changed, the name is my TWA, and we are connecting. There was an error that was not obvious to me, friends. When connecting my wallet, my balance and the address of my Jeton were not pulled up, and the solution to the problem helped to change the import in our builds. For now, let's just take this as given. This is errors that you are unlikely to face. Therefore, in order to not expand this video even more, we will not to delve into it. The main thing is that our site is working now, and we are ready to connect it to Telegram. To start, we need to use bot fuzzer to create a new bot, which we will call Alifman123 bot. After we have created the bot, we go to Settings and configure the Menu button tab. We are asked to provide the URL of the site we want to connect to the bot. After doing this, we are prompted to name our button, which we will call Open Up. Now our bot is ready, and we can launch our application by going to the bot. I press Start, and we then see the Open Up tab. We can also run the application from our phone for better demonstration of how it works. We go to the bot, press the Open Up button, and our bot loads. At this point, I am automatically connected. To show the full process, I disconnect from the bot, then I return back and press the Connect Wallet button. I am given a choice of which specific wallet I want to connect. I choose TONConnect, confirm the application I am connecting, and press Connect. And this action automatically returns me to my bot. And now all information is saved, my wallet is connected, and I can see my balance and Jeton wallet. And let's to test the mint Jeton function. I press the button, confirm the transaction, and I automatically return back to my Telegram. I get a notification that I received 150 jetons, and my balance updates automatically. Congratulations, we have now completed the full course. Thank you to those who have watched the course to the end. You are now ready to identify yourself as a TON developer because you have taken the first steps. You understand the basic principles on TON development. I encourage you to actively participate in developer chats, ask and answer questions. Such participations helps the community to develop and become stronger. Also, there is a lot more to learn about TON ecosystem, like TON storage, TON sites. TON is also a multi-chain blockchain, meaning we can work across multiple blockchains. But right now we have taken the first step. We can now create apps in Telegram and TON ecosystem and be among the first to launch them. This is an opportunity to enter a new market with a small number of existing applications. And I wish you good luck, happy coding, and goodbye.